What's up, guys? Back here with composite functions and asymptotic behavior. So a composite function, very simply, is a function of a function. Kind of like when we put g of f or g of x inside of f of x. This isn't new, so we've seen all this before. Very quickly, f of x is x squared. G of x is x plus 1. So if you put g of x inside of f, you plug in x plus 1 into x. You get x plus 1 squared. So to find f of g of negative 2, you're going to find first f of g of negative 2. First, you figure out what is g of negative 2. So if you put a negative 2 in here for x, you're going to get negative 2 plus 1 is negative 1. So it really wants to know what is f of negative 1. So you take f of negative 1 squared, which is 1. Right? Pretty simple. G of f of x, flip it around. So g of f of x, you're going to put f of x inside of g of x. So x squared is going to go where x is at. Right? That's all there is to it. Okay? Now, suppose that f and g are given on graphs. Here we have some graphs, right? And for those graphs, we have to find f of g of 1. Here's f of x, here's g of x. They want to find f of g of 1. Well, first thing you need to do is figure out what g of 1 is. They're really wanting to know what is g of 1. So go to 1, find g, it's negative 1. Go to negative 1 on x and find f. Negative 1, f, negative 2. For example 4, g of f of 0. Go to 0, find f. It's 0, right? So they really want us to find g of 0. So what's g of 0? Go to 0, find g. It's 1. Fantastic. Sketch f of g of x. Now this is where it gets a little interesting. So you would have to do that for any number of points that you pick out of there. Now we can take some time to do that. I will tell you that when you go through and you sketch these, what I would do is go ahead and pull out some x values and then find g of x and then find f of g of x. Now for x values, what I would do, I would use anything that could possibly give you a decent value. All right. So again, this is me. What I would do is go through and do your whole numbers. So negative 2, negative 1, 0, 1, 2. And I would go through and figure out what g of x is, plug that in for f, and graph it. Once you graph it, you're going to end up with something along the lines of this. Roughly. All right. You're going to end up with something along the lines of that. Not exact, but something along the lines of that. I'll let you take care of that on your own. I'm not going to sit here and make you wait for me to work that through. So let's go down to the bottom here, vertical asymptotes. Again, we're still on our pre-cal review limit. So vertical asymptotes, we're looking at denominators mainly here. Now what's the special thing we all know about denominators? That they cannot equal. They cannot equal 0. So where will this denominator equal 0 for this bottom one here? We've got x plus 2 on the bottom, so set it equal to 0. X plus 2 equals 0. Solve for x. And we say that the denominator cannot equal a negative 2. Therefore, the vertical asymptote is at x equals negative 2. That is your vertical asymptote. It will not touch that line. Over here, your denominator, right? X cannot equal two numbers, negative 2 or positive 3. I got that by setting those equal to 0. Set each one of them equal to 0, solve for x. X cannot be these numbers. Therefore, you have vertical asymptotes at x equals negative 2 and 3. Pretty simple, right? Find where your denominator is equal to 0. Say x cannot be that. Okay? Pretty straightforward. On the next page here, horizontal asymptotes. All right. Horizontal asymptotes. Divide by the highest exponential power. Divide by the highest exponential power. Now for this one, there's a couple of rules that you can go by as far as what you can follow. The easiest way to remember these is if they have the same degree, then your horizontal asymptote, oh, I'm sorry, you can't see that. Same degree, then your horizontal asymptote is simply A over B. A being the first letter here, B being, or first number, I'm sorry, B being the first number down here. The reason for that, and there is a very long reason for that, you're dividing the highest power by dividing by the highest exponential power. The highest exponential power is x squared, right? So if we were to go through and divide everything by x squared, and we were to get 3x squared over x squared plus 2x squared over x squared plus, or excuse me, minus 3 over x squared. And then we got 2x squared over x squared plus x over x squared. This doesn't have a square on it, does it? I'm all over the place today. And minus 2 over x squared. All right, eventually what you're going to get is something that simplifies out to this. X squared over x squared, 3 over 2 plus 2 over x minus 3 over x squared plus x over, 1 over x. What am I doing? Minus 2 over x squared. After you simplify. Now notice that as x is going to increase, the bigger that x gets, the closer all of these go to 0. You're looking at what is x approaching. So we just say right back over here that our horizontal asymptote is 3 over 2. Now I'm not going to go through and show you the reasoning behind all of these. You can pretty much work it out the same way doing it this way. If your exponent is bigger on bottom, like this one, 2x squared, your horizontal asymptote is y equals 0. That's easy enough. That's your answer. That's all there is to it. Y equals 0. That is all there is to it. Lastly, bigger on top. That means that there is none. H-A, none. There is no horizontal asymptote. That's all there is. So again, if you want to see, this up here is the reasoning behind this. If you want to see it, fantastic. Work it out. You'll see why. But trust me, bigger on bottom means it's y equals 0. Bigger on top means it's none. Same degree means it's a over b. Easy peasy, breezy, beautiful cover girl, right? So, it says given the following function, let's come up with some information on this. It says the domain. What is the domain of this function? Well, first, let's factor that function. I want to factor it. I don't like seeing that function written like that. So on the top, we should all be pros at factoring. X minus 3 plus 2. On bottom, X. We need something that adds to 9 and multiplies to a 9 and adds to a negative 6, so minus 3. Alright, so there's a lot of information that can be gathered from this thing. Mainly about vertical asymptotes, horizontal asymptotes, so on and so forth. Okay? For this one, when we set this thing up, notice that these are the same, right? These powers are the same. What did we just learn about horizontal asymptotes when they're the same degree? It's A over B. Easy enough. Horizontal asymptote happens at y equals 1. Vertical asymptotes. What can y not be? Or excuse me, what can the bottom not be? What can we not plug into x in order to make this thing undefined? What can x not be? X cannot be 3. That's your domain. Easy. Alright? Now, as far as y-intercepts go, or excuse me, intercepts, we'll get to that in just a second. Let's do vertical asymptotes real quick. Vertical asymptotes, since x cannot be 3, that's your vertical asymptote. Alright? Now there's a couple of things that we want to point out about this real quick. For your intercepts, we have an x-intercept right here where x is 2. Since these will cancel out and everything will go away, yada yada yada, x is going to end up being 2, right? Say these go away, we get rid of these. If I'm trying to figure out my x-intercept, all I'm looking for is what in this situation, what would happen, say I plug in a 0 for x. Now, I don't care about what's happening down here. I'm talking about just the numerator. I'm looking at if I set this thing equal to 0, not plug in, I'm sorry. If I set this thing equal to 0 and I solve x plus 2 equals 0, what is that going to give me? It's going to give me an x-intercept of negative 2 comma 0. Now, if you plug in a 0 for x, you get 0, negative 2 thirds. That's your y-intercept. Technically, this guy right here, x minus 3 over x minus 3 was a whole. It was a whole, but the asymptote will override it. So for here, there's none. Sketch the graph. All right. So we know that there's a vertical asymptote at 3. 1, 2, 3. We know there's a horizontal asymptote at 1. Now all we need to do is a sign test. That's where we plug in values and see what the signs are going to be. So a sign test, if you take your function, we have zeros here, possibility for zeros, let's say at negative 2 and 3. Those are your intercepts. Those are right about where your intercepts are at. Let's say negative 2, we'll say 3, we'll see what happens. We know that this is going to happen at 3. We also know it has an intercept at negative 2. So we can label that point. We know the y-intercept is negative 2 thirds. So we can label that point. So if you kind of follow what's going on here, you can do a sign test, go from negative 2, and we'll do one over here at 3 as well. If we plug in something into this function that's less than negative 2, we're going to come out with a positive answer. Plug in anything in between negative 2 and 3, we're coming negative. Plug in anything to the right of 3, we're going to come out positive. We'll get into more of this sign test stuff later. Don't worry about this so much right now if you don't understand this. This is just mainly review. It's meant to be a little fast-paced. I will drill this in a little bit later. So it goes positive till it hits -2, then it goes negative, and it keeps going negative until it hits 3, and now everything is positive. That's it. That's all there is to it, except that it will not pass those asymptotes. So take a second, review over this. I know it was very fast-paced, but take a second, review over it, and we will kind of discuss the sign test a little bit more when we get into class.